Hi everyone. Today what we're going to work on is solving a system use of inequalities. Okay, so solving a system of inequalities. System of inequalities. And this is like the last section from our last chapter, but I wanted to stick this. We're going to touch bases on this. This actually will be pretty easy. If you guys can catch it. If you guys can catch it, it's actually pretty easy. But oftentimes teachers will spend like a week or two on this. But I think it's all about if you can catch it. Okay, if it makes sense, if it clicks for you. And I'm going to try to make sure it clicks. Okay, so let's talk about inequalities again. Inequalities are, remember these symbols of equals, greater than, not greater than or equal to, or less than or equal to. Also like their little cat eyes or something. Okay. Greater than, less than, and these symbols represent not one solution, but a vast domain of solutions. What I mean is, if I say, "Hey, I'll be home after 3 o'clock," or sorry, I'll be home at 3 and after. Okay, I'll be home at 3 and after. What does that mean? Let's draw this on a number line. This means you can visit me anytime after 3. Including 3. So what if I stop at 4, at 5, at 6? What if I stop by at 3:30? Yeah, I'll be home. I'll be home at 3 and after. Okay, 3 onwards. Maybe you can say 3 onwards. But what if I write, I'll be home after 3? So we are saying don't include 3. I'll be open like at 3:01. Okay, anytime after 3. And remember, one is hollow and one is solid. And that was a big difference between equals and not equals. Am I going to include it or not include it? Again, if you remember, we talked about this as sports. If you are dribbling the ball in basketball and you have the ball, if you step on the line, are you in or out of the game? If you step on the line in basketball, you are out. Okay, so it's very similar, like the idea of solid and not solid. Am I going to include that in the game or not include it in the game? Now, if you're equal to, that means you are including it in the game. Okay, now when we graph this as a graph, we kind of changed up. We said y is greater than or equal to 1/2 x plus 2. Let's go ahead and graph that. Now, since it's x and y plane, not only are we looking at x's, but also the y's. We graphed it as y is greater than, so 1, 2, put a dot. And the slope is rise 1, run 2, put a dot. And then we have a solid graph here. Now, what if I graph this? Okay, let me go ahead and remind you guys how to graph this. It's from here, y is greater than. See, y is greater. That means it's not just going to be one solution, but it's all the y's that are greater. Now, let me make this a little easier for us to see. What I mean is, if y is greater, that means all the y's are greater above all the points of my line. And if you look here, I'm just drawing arrows because from the point onward, we're saying, hey, totally cool. These are all answers that are okay. Now, girls, I know you're not into marrying someone just because they're rich, but wouldn't it be nice if they were rich? Right? So everyone has an idea of how much money is rich. So the idea is after this value, yep, we're rich. And depends on where you are in life, the value changes. If you're in high school, if you have $100, you're rich. If you are in first grade, you have $5, you're rich. Right? But if you're my age, if you have $100, that doesn't mean you're rich. So what happens? It's a sliding scale. And everyone has their own equation here. In our equation here, we're saying as long as y is greater than that line, we are rich. Okay. So I'm going to change this graph slightly. I'm going to say the same thing. Y is, let's use greater than, not equal to, and then we're going to draw us the same equation here, 1/2 x plus 2. And we'll see that this graph looks almost verbatim exactly the same. 1, 2, put a dot. The slope is rise 1, run 2. And this time, instead of using a solid line, we're going to use a dotted line. Okay, and this is, again, just review. As you guys can see, the lines are, oh my gosh, I made them so parallel, right? They look pretty darn good. And since we are greater than the line, we are above the line, we are greater than, we're rich up here, rich in spirit, rich in cash. Now, careful, this goes all the way up. So when we're shading it, we're shading the whole graph on top. Now, please be advised the difference between solid and dotted. The dotted or dashed line, sometimes we call this a dash line, is that it's almost like this invisible barrier. Don't touch it. It's just there to help you contain your graph, Versus the solid line means you can actually play on this line. Okay? So the line that's solid means it's included, it is equal to the line, equal, or greater. Versus just greater, not equal to. Okay, so make sure that's clear in your head. And that's always a trick. Sometimes you're rushing through the problem and you don't catch that dotted or solid part. In IXL, you will have to know the difference between solid and dotted. Okay. Now, I want to throw up something here. I want to ask you guys a question. Let's test the solution for this problem. Is 0, 5 a solution for y is greater than 1/2 x plus 2? Okay, is this a solution? Now that's, since we have the graph drawn already, that's fine. 0, 5, 0, 1, 2, 3, 4, 5. Let me use a different pen here. 0, 1, 2, 3, 4, 5. Is 0, 5 a solution? Is this in my shaded region? And it is. So what that refers to is that if I plugged in 0 and 5 into the problem, this would be a true statement. 5 is 5 greater than 1/2 0 plus 2. 5 is greater than, this is 0 plus 2. 5 is greater than 2? Yes. It turns out all the points in the shaded region would make this a true statement. Why? Because those are all the y's that are greater than the line. All these y's are greater than the line. All these y's here are greater than the line. So all those points are possible solutions. And that's the thing that we're talking about. In the reality, it's not an equal sign. It's never just a line that's the only answer possible. In reality, if I ask you, well, I shouldn't keep using dating as an example, but in reality, we always have a range of answers, right? So example, a dumb one is, hey, when do you sleep? And then it's never exactly 10 o'clock. At 10 o'clock, I close my eyes and I'm asleep. Usually you say, oh, I sleep after 10. Or I sleep before 12. Or I sleep between 10 and 12. It's always a range of answers. It's never just one answer. And sometimes people use the word tolerance. There's a tolerance, right? A plus and minus. A little bit of a give both ways. And that's what inequalities really refer to. There's more than one answer. Life is more of a range, not just one solid. Okay? Okay, so now what we're going to do today is we are going to test if a system, we'll look at what a system of equations looks like, and I'm going to graph two things together. So I'm going to graph y is greater than or equal to 2x plus, let's do 2x minus 1, and we're going to do y is less than negative 1/2 x plus 2. Okay, so let's go ahead now and graph the system. Now this is a system of equations. Okay, so since these are already set up for us to graph, let's go ahead and graph them. I'm going to actually change the right one, and I'm going to put this in red. Okay, I'll use this in red, and I'll use this guy in blue, just so you guys can see that. And then since I'm going to do that, I'm going to erase this and just use black here for the setup. Okay, let's draw my blue line first. We are at negative 1, and the slope is rise 1, 2, 2 over 1. Hopefully you guys remember how to graph lines. And ask yourself, would this be solid or dotted? This would be a solid line, okay? So I'm going to draw a solid line here. Okay, now at this point, I could start shading. Y is greater than the line. So it's above the line, above the line, above the line, above the line, okay? But I'm going to leave it off for now because we're going to come back to that in just a moment. And then the second graph, that's going to graph this in red. We're at negative, or so positive 2. 1, 2, here's 2. And the slope is negative 1 over 2. Negative 1 over 2. And this is going to be a dotted line. Make sure you guys do draw a dotted line. That does matter a lot. A dotted line. Now, I am now going to shade, and we're going to figure out at what region are they both cool with it. Okay, now at what region do they both agree? Now this is similar to, let's say your parents said, I will buy you guys ice cream. You and your brother, you and your sister, whatever it is, I'll buy you guys ice cream. And they'll say, but you guys have to decide what flavors you guys want. Because you guys only have one scoop, but you guys have to share it. So you guys both come up with examples. Like I'll say, I like chocolate and vanilla. And you might say, I like chocolate and strawberry. And you guys see, do we agree with chocolate? Fine, we'll get chocolate together. That's a solution that we can both agree to. That's what we're going to do today. We're going to say, okay, so y, let's look at our first blue equation. Y is greater than the line. So I'm going to go above the line, okay? Take a look here. Make sure you do go all the way across, okay? Make sure that looks a nice box. Now my second solution is in red, and we say y is less than. See, y is less than? Y is less than. Now, you'll notice that there is one region that's double marked. And this double marked region means all these answers, all these points in this double marked region are going to be true for equation 1 and equation 2. And that's really today's goal. The goal is to figure out what region, what area is true for both these sections. Now, I'm going to reteach this in a slightly different way, because shading is great, but me having a smartboard, having a tablet here, or maybe having highlighters would be super helpful. But I actually am kind of cheap and I don't like using highlighters. So let me show you another method I use to shade. And that's just drawing simple lines. So if you guys want to redraw this, or you can draw this on the side here, right? You can draw this on the side, right? Draw this on the side, whatever. And take a look at how I rather shade. I'm just going to draw lines with my pencil going up like this. This is the long way of doing it. As you guys can tell, I'm shading, right? Essentially, I'm shading. Or you can use your pencil and shade lightly. That also works. There's a lot of different methods. Unfortunately, we're distance learning, so I can't be in front of you guys to help you guys out a little bit more. And we said, whoops, sorry. Man, I drew it the wrong way. Y is less than for the red, isn't it? Y is less than for the red. Y is less than. So I went the wrong way. So Y is less than for the red. And for the blue, Y is greater than. So instead of drawing up and down, I'm actually going to draw it a different. Now, can you guys see in what area is this double shaded? In what area is this double shaded? You guys can see that it's double shaded in this area right here, right? Okay, I got one more for you, right? Because this to me also looks kind of too many lines. Now, here is, I think, the easiest way of doing this. Here we go. Here's the easiest way. Anyone here agree with me that shading might take a lot of work, drawing lines might be a little confusing? Instead, I want you guys to notice this idea right here. There are, whenever you draw two lines, it will cut it into, for the most part, like 90% of the time, 4 sections. 1, 2, 3, 4. Now, which of these sections would agree with both these inequalities? Which of these sections? Now, here is the thing I want you guys to notice. Every time I draw a line here, it breaks it up into two parts. See, there's a left and a right part, right? There's two parts. There's one and two parts. Okay, there are always two parts. Now, I'm going to help you guys do this in a super ridiculously easy way. It's going to be ridiculously easy. All you have to do is make sure you know which way you're going to draw the arrow. Now, let's look at the first one. Y is greater than 2x minus 1. So for the blue line, I'm going to draw an arrow above here. Watch. Y is greater and y is greater. Do you guys see that I captured the two sections? I captured the top and I captured the bottom. Okay? That's it. Just draw two arrows. Let's draw the two arrows for my next line. Y is less than the red line. Y is less than, y is less than. Let's examine these four quadrants again to see which of these have a double coverage. Looking at my first upper left. Do you guys see how there's only one arrow there? So do they both agree? Nope. Looking over here. Do I have any arrows there? Nobody agrees. Nobody wants this. Looking down here. Only one arrow, right? Only one person agrees. Nope. And then looking in this region here, look, you have to go through the x-axis here. Remember, you're only graphing between the lines that you drew. And you can see that this is double coverage. Right? Now everyone agrees here. They both agree. And that's one method I think was the easiest method when I'm teaching these inequalities. If you just draw little arrows, you don't have to draw 1,000 of them, just draw two. And you can see which area is covered by both equations. Now what does this mean again? This means that any answer that you plug in here, let's pick a number. Let's say -2, 0. You guys see the -2, 0 here is inside the shaded region? Would -2, 0 be true for both equations? Let's go ahead and plug in our math now. If x is -2 and y is 0, would this be true for each of these equations? Let's go ahead and plug it in. I'm going to plug these in now. 0 is greater than 4. Whoops. 2 times -2 minus 1. And 0 is less than -1/2 times -2 plus 2. Let's see if these are true statements for both of these. 0 is greater than -4 minus 1, which is 0 is greater than -5. Is 0 greater than -5? Yes, that's a true statement. On the right, is 0 less than 2 divided by 2 cancel out, so that'll be plus negative is a positive 1, plus 2. Is 0 less than 3? Hey, yeah. -2, 1 is a point that's true. But know what? That's not the only solution. Any of these points inside that shaded region are all completely true also. All these points work. It's a region that's true. If I pick any point outside that region though, this would not work. These would not work. Points over here would kind of halfway work, but they are not true for the whole system. All right? Points over here would only halfway work. Okay. A lot of sad faces going on. Okay. So that's really what you guys are going to do today on our homework assignment. So let's go ahead and visit that real quick. We have 2 homework assignments you guys are working on, T5 and T6. Let's go ahead and check IXL here. We're on class. Okay, the first question is, hey, would this be true or not? Is 5, 10 true for this system? So what you're going to do, you're going to go ahead and plug it in and check it. Let's go ahead and plug in x and y. Careful, make sure you get this. Sorry, make sure you get this correct. X and y. So 10 is greater than 5 plus 4. Is that true? And x, what's x? X is 5, is less than 10. So is it true? Is 10 greater than 9? Well, no, that's not true. That's bad. Is 5 less than 10? Yeah, that's true. But they both have to be true. So it is not a system of the solution. It is not true for everyone, for all the players. Okay, so what we're doing, you're just going to plug it in and see what it looks like. Easy peasy. We said no. Wait, what? Oh, oops, I drew it wrong. Uh-oh. I drew it wrong. Whoops. Oh my goodness. Did I misread that? I totally misread that. Y is greater than 5 plus 4. Is 10 greater than 5 plus 4? Oh my goodness. 10 is greater than 9. I think I flipped around the inequality on accident. Sorry about that. My goodness, copying it. That's a big deal. Okay, let's do something a little harder here. So the problem looks a little tougher, but we're testing if this is true. Is the point x negative 5 and 8y being y, would that be true? So 12 times negative 5 plus 6 times 8, would this be less than or equal to negative 12? Would 6 times negative 5 and negative 4 times 8, would this be greater than negative 10? I don't know. And you can use a calculator on this, but you have to first set it up. To show work, you must set it up. That's negative 60 plus 48. And if I subtract it, that's going to be negative 12, right? Negative 12. Yes, and negative 12 is less than or equal to negative 12, so we are okay here. This is negative 30 minus negative 30 minus 32. That's negative 64. Is negative 64 greater than negative 10? Looking at a number line, if this is negative 10, this is negative 64. Is negative 64 bigger than negative 10? No, it's less. If you owe me $64, you are poorer than the guy owing me 10. So negative 10 is greater than negative 64. So you're going to plug it in and check, and my answer is going to be no, that's not a solution. And hopefully I got the inequalities right, and that worked out. Okay, so that's what you guys are going to do for the first part. The second part is you guys are going to graph the system of inequalities now, and that is T6. Now I wanted to give you guys some examples here because they're going to ask us to graph horizontal and vertical lines, and I want you guys to remember how to graph these. So the first problem is y is less than 2. So y is 2. Think of it. Y is 2. 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 Y is all 2 here. See, y is all 2. It's not a horizontal line. It's not a vertical line. It's a horizontal line. So a couple things I want to graph here is first, this is less than, not equal to. Less than, not equal to. Right? So we get to pick shaded, not shaded. Sorry, dashed, not dashed, if you guys can see that. Let's graph the second one. X is less than 6. X is less than 6. So X is 6. Here's X is 6, folks. X is 6 right here. That's why it's a vertical line. So make sure you do practice that. A lot of kids still make mistakes on that. And we are using a dotted or solid. It's harder to see this one, but this is also a dotted line. Now the follow-up question to this is, let's go ahead and shade it. Which way would we shade? Now I'm going to show you how to draw this using arrows. Y is less than 2, less than 2, less than 2. You guys all see I chose it on both sides here. Right? Remember how this is my dividing wall? We're going to draw an arrow down on both sides. The next statement is x is less than 6. Okay, x is less than 6. Well, is this less or this less? Well, less means smaller than 6. So 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Now, looking here now, which of the 4 sections, 1, 2, 3, oops, sorry, I missed that one, and 4, are these two the same colors? They just color the same color. Me being colorblind is not helpful to anyone. 3, and then 4. Which of these 4 sections here are double covered? It's my lower left section, right? So that's what we're going to do. You're going to click on shade. See the word shade here? Oops, see the word shade? Uh-oh. And we're going to shade which section here? Which of these 4? And we say we're going to shade that corner. The cool thing about IXL, this makes it super easy to shade. The problem is, if you're not careful, you might shade the wrong corner and get this wrong, which is a big deal for us. Okay, let's go ahead and solve this next one. We're graphing negative 4. X is negative 4. Here's X. And X is negative 4 here. I'll see X is negative 4. 2 dots. This is going to be dotted because this inequality is less than, strictly less than, not less than or equal to. And we have Y is equal to 3. Clicking Y is equal to 3. Here's 3. Y is 3 up here. You guys all see Y is 3 up here. And we are also using a dotted. So tap it again, you get a dotted. Now, here's the part that the shading part. So if I choose, let's look at the first one. X is less than negative 4. X is less than negative 4. You guys are cool. X is less than negative 4. Now, which of these two options is Y greater than 3? Which of these two options? Which of these two options here is Y greater than 3? Well, Y greater than 3, that means we have to be on top here. So we know that we're shading up on top. So this is less than 4, negative 4, but also greater than Y is 3. Okay, excellent. Let's go ahead and jump. We're going to graph some lines here. Now, since this is in slope-intercept form, this is pretty easy to graph. Let's graph the first one. Y is less than negative 3. Y is less than negative 3. Everyone cool? Y is less than negative 3 down here. Ask yourself, is that going to be a solid or dotted line? Solid or dotted line? Dotted or dashed, depending on how you want to talk about this. It's going to be a solid because we are equal to. The second equation, lost that one. Second equation is y-intercept is negative 4 and the slope is positive 4. From here we count 1, 2, 3, 4 over 1. Solid or dotted, that's going to be solid for us. Now, if you look at the shading area, we have these 4 sections. Now, since this graphing utility is actually very easy for us, let's just go ahead and answer our first part. When is y less than negative 3? Here's our negative 3. So when is y less than negative 3? Well, less than negative 3 means you are less than negative 3. Our y values are less than negative 3. How about the next question? Y is greater than the line. Y is greater than the line. Which of these would demonstrate y is greater than this red line? Now, let me go ahead and quickly or show you how I would look at that still. This red line here, y is greater than. We are greater than. That means we're above this line, aren't we? And we're not allowed to be up here. We already discussed this is wrong, right? This is bad. So we're less than but greater than. So we're actually this lower left-hand corner. And this is where kids get stuck, because if the line is almost too vertical, kids get confused what is greater than or less than. And that's where I ask kids to go ahead, put your pencil on the line. And isn't greater on top? Isn't greater on top? Isn't greater on top? Well, Mr. Ko, we're looking greater this way. No, 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 no. We said y is greater here. Well, the y values are greater. The y values are greater. Okay, so we can see that there's only one reason that makes this true. Not only are we less than y is negative 3, we're also greater than that line. Okay, So I think this is something you guys have to practice out and work it out. It shouldn't take you that long because this is mainly just review and we're just combining our skills that we learned before. Cool. Thank you.